All right, everybody, let's go ahead and look at how we can put some of the stuff that we've done in the past into practice. So what we're going to actually do is we're going to go ahead and conduct a t-test. And here's our scenario. Collectively, we are a group of scientists in this class, and we have just designed a diet pill for individuals to help them lose body fat. And now we want to see if this diet pill has any effect excuse me, has any effect on actual body mass loss. So let's say hypothetically we had all the presidents actually with us, and we conducted those individuals were our sample. So first of all, let's go ahead and just create a table with this data. So first thing I'll do, I'm going to collect in this field of data. I'm going to insert, select table. Yes, my table has headers. And what we're going to name this is body mass underscore lost. Hit enter, and there we go. We have a table. But now I want to conduct both an independent and a dependent t-test with the data I have. And again, this is going to be hypothetical. So what we're going to do first is we're actually going to extract some of this data. So what I'm going to do is I'm actually going to steal some of these headers, and what we need is name and body mass loss. So copy that, go over to independent, and last thing, we're actually going to gather this value as well. So what we're going to do is we're going to actually have the list of names. We're going to copy the list of names over, and we're going to have Excel tell us to actually extract the name to the respective header. So for the sake of it, we're just going to go ahead and copy these values. Copy. Now the reason why I'm showing it to you guys this way is because in some cases, you actually might have a whole host of data that draws out all the way out. And in some cases, it's actually easier to kind of pull certain variables from your data set into other workbooks like we're doing now. So rather than going back and forth and copying from tab to tab, we're going to have Excel, like I said, extract that data for us. So first thing is, all right, so we have our names, and we want to extract that data from our table over here into this other tab. Now let's go ahead and do that. So let's go equals index, and what we want to look up is body mass lost. And the first row is we want to match this value in the corresponding table. So we want to match James A. Garfield, and the lookup array is body mass lost. Better yet, let's just click over, and we want to look up in this table, highlight those names, body mass lost. We want an exact match. So now we want to look up the column, and we just delete this. We want to match body mass lost, and that independent doesn't need to be there. It's just stating what tab is going to. So we want to match E3. What value do we want to look up? Well, we want to look up the headers here. What match type? 0. Exact match. One more close parentheses to tell the Excel that we're done. Hit enter, and voila. Now, as you see, James Garfield lost 8 pounds. Let's just double check that. And that actually is wrong because we had something missing. So let's go ahead and redo that. So just delete that. Equals index body mass lost. We want to match this value D4. We want to look up array and body mass lost table. We want the name, an exact match column. We want to look up value this, and array is body mass lost headers. All right, let me just go ahead and replay that through because sometimes that can be kind of confusing. In fact, I'll just go ahead and delete it. The reason why I had it set up on a table, so that way we didn't have to keep flipping back and forth from tab to tab. So, and again, sometimes I need to practice myself. So index, remember we're going to index that whole table on the data tab, right? So I type in equals index. You can double click it or hit tab and it automatically locks that formula in. Now what's the array of data that we're going to look up? Well, it's, remember, body mass lost. If you just type in BM, hit tab, and it locks it in. The row number we're going to look up is what we want the row numbers. We want to match that name to the corresponding data. So we want to match, look up that value. Where do we want to look it up at? Well, it's going to be BM lost. Now to get this thing right here to pop up, you have to hit that little bracket key, and we want name, close bracket, comma, and we want an exact match, close parentheses, and now that completes the row part of this. Now we want to look up the column. Column is we want to match body mass lost. We want to look it up in the body mass lost table. Where do you want to look it up at? Well, we want to look it up in the headers. Kind of match type? 0. Close parentheses. Now that doesn't complete the thing. We need one more close parentheses, kind of as you do in mathematical notation. Close it there, hit enter, and there we go. Now it's all locked in. Just to kind of look over, let's see if our data is right. James A. Garfield, yes, he did lose 1 kilo of body weight. Now we're not necessarily done. Let's go ahead and take this value and we're going to drag it over, and we should get an NA. So there's a couple things that need to be adjusted here. Notice in our formula, it's now, because I dragged it over, I didn't lock anything in, it's pulling over there. I could simply just drag that over to James Garfield, and it also dragged into diet placebo right there. Now to easily do this, one thing that needs to be changed, this header right here would also have to be changed. So we would need diet placebo, close bracket, hit enter, and that didn't work. So let's just go ahead and restart this. Equals index array body mass lost. Where do we want to look up? We want to look up James Garfield. Well, actually we want to match it. And where do we want to look it up at? We're going to look it up at body mass lost table. And we want to look up in the diet placebo. Close that. We want an exact match. Now what column we want? Well, we want to match. We want to match that column, F3, comma. Where do we want to look it up at? Body mass loss table. Where exactly? Let's look it up in the headers. And we want an exact match. Close parentheses, enter, and we still have a problem there. So let me pause this. Okay, not sure why that wasn't working last time, so let's just go ahead and do this again. And what I'll do is I'm going to copy this, and I'm going to paste it. Oops. Better yet, I'm going to copy this, paste it there. That way I can kind of get a reference of it. Sometimes it can be a little tricky. So we want to index the name, James A. Garfield, comma, row number is, we want to index body mass lost. The row that we want to look up is going to be matching James Garfield. We want to look up that value in body mass lost. Name. We want an exact match. Now we want to look up the column, right? So we want to match F3. Where do we want to look it up? Body mass lost. And we want to look up in the headers. And again, we want an exact match. Close parentheses, hit enter. And there we go. So James A. Garfield he lost 1 pound and he was on the placebo. Now what we're going to do is we're going to quickly get all this data for everybody there. To do so, we have to lock a couple things in place. See this here, E3? We want that to stay in place. So to do so, we're going to hit F4. So now it automatically pulls there each time. Same thing here. We want to lock that one in there. Hit F4. Now the reason why I didn't lock this one is because when it drags down, I want them to pull each respective value. So when I double click this, it should give us the correct values. And there you have it. So now we have all of our data with the body mass loss with the respective data regarding whether or not they were on the placebo or the actual diet pill. Okay. Now again, we want to run a t-test, an independent t-test. So in that case, some individuals were on the diet and some individuals were not. So to do so, let's just organize this. Let's highlight this, and we're going to filter it by going to data, filter, and we're just going to put smallest to largest. Now I know who was on what, kind of in an organized fashion. Now let's actually run the actual t-test on our data, and it's actually quite simple. So for the placebo, we're just going to highlight this data, and then for the diet pills, we're going to highlight this data. Well, to do so, we need to go into our data tab and then hit data analysis. Now the problem is some of you guys don't have this data analysis tab, so we need to get that for you guys. To do so, go into File, go to Options, Add-ins, and then where it says Manage Excel Add-ins, hit Go. And you'll notice right here where it says Data Analysis Toolpack, Analysis Toolpack VBA. Click those two, and maybe if you want to add in Solver add-in, hit OK. And when you do so, the Data Analysis tab should appear in your right side. And this is where we're going to run most of our statistical analysis. So we have our data collected and organized. We hit Data Analysis. And the type of test we want is a independent t-test. Now you'll see here we have three different options to choose from. Now the first one here, a paired sample t-test, that would be for a dependent t-test, meaning that all our samples or all our subjects would have done the diet, pill, and the placebo. But in this case, we had one group do diet and the other group do a placebo. What we're going to choose is we're going to choose t-test sample assuming equal variances. I won't get into the differences between there. It's an assumption that needs to be met in statistics. It goes a little advanced, but we won't go in that just yet. So we're going to pick t-test to sample assuming equal variances, hit OK. Now our variable range 1 was we want to select all the people who were in the placebo. So this one, all the way down, good. Now we want for this, the variable 2 range is we want to pick all the ones. So select down. Remember this code means they were on the diet pill. Good. We're not going to check labels, and we're not going to check mean difference. It's going to default to 0. Now the thing is, you'll notice this says alpha. Alpha level is basically a set margin for, or set probability to where you will say, hey, your data is rather statistically significant or not. Typically, it's always set to 0.05. The only time you would change that is if you have support or scientific evidence to show that it might be higher or lower. So right there, we're just going ahead and leave it there. Now we want to an output range. We just want to keep it on this sheet. So we'll click output range H3 and hit OK. And we need to do this real quick. So there we go. Now we have our data analysis. Let me kind of explain what all this is. So the mean body weight loss for the placebo, and we can just go ahead and label this, and then diet pill. The mean weight loss was about 3 kilograms, but for the diet pill, it was 7.5. That's a huge difference. The variance, or the standard error, was 2.3 kilograms, meaning that's how spread out our data is. Observation, that basically means how many people were in each group. For the placebo, we had 19, and then for the diet pill, we had 25. You don't need to worry about this or this, but what you will need to look at is these values right here. You want to look at this as well as this, and basically these values tell us whether or not that statistically is the diet pill. Is there a 95% chance that this diet pill was different from the placebo? In this case, it was. Our t-value is actually 2.01. Our p-value, if you'll look here, is 8.6 to the negative 12. Basically, another way to write that is 0.0 with 11 zeros. I won't do it all. And then 8.6. That number is definitely smaller than 0.05. So we can say statistically that yes, our diet pill is statistically different, or is different from the diet pill, and we could recommend that this would actually help individuals lose body weight. So as you can see, that's actually quite simple, as Excel does all the statistical analysis for us. Now that was actually for the independent t-test. Let's go ahead and do the dependent t-test. Now for the sake of time, I'm just going to go ahead and copy this data and paste it. And what we'll do now is we need to create another tab. Let's call this body weight lost P, and that's when they're on the placebo. And we're going to call this body mass lost diet pill. Now this data here is just going to be made up data, and we don't need to use the tab anymore, just so you guys can see how this is ran. So let's just assume that on the placebo they're not going to lose as much weight. So we're going to just put some random data. And let's say it's anywhere from 1 to 5 kilos. And then on the diet pill, equals rand between, and let's just say they've lost anywhere from 5 to 10. Again, this is for just to show you guys how. Select this data. Okay, so now in the last case we had 19 in one group and 25 in the other. Now in this case we're going to actually have roughly 44 actual participants, because remember, a dependent test, we had them do one scenario and they come back and do another scenario, or one aspect of the experimental design. Again, it's actually quite simple. We go to data analysis. In this case, you go to paired two sample t tests. Hit OK. Arrange the variables for the first one. It's here. Range of variables for the second one is there. And we want a new output range. Let's say H3. Hit OK. Let me redo that, because I kind of just hit OK without. All right. So yet again, we're looking at variable 1 is placebo, and then diet pill. On average, they lost 3 kilos. For the placebo, on average, they lost 8 kilos for the diet. Again, here's our spread of our data. Here's the amount of participants that we had. And again, we want these values is what we're really looking for, right? You have a two-tail test, and I'm going to cover this later on. But what this is saying is that our t-score is 2.01, and for our data, that's associated with the probability value of 2.1 to the negative. Again, that's saying 0.0 with 19 zeros, 211, and the rest of that number. And yes, that number is less than 0.05. So we can say that our diet pill is 95% different from the placebo. That concludes this video, guys. I hope that clarified on how to run a t-test, what it's for. You know, it's just comparing means, and how to interpret what those values are and its corresponding probability value.